Welcome. So we are at the end of Module 3. So this is your Module 3 learning check. If it is a quiz one, answer the questions that come up and just make sure you submit at the end once you're happy with it. So you can restart as many times as you need to. But make sure at the end you watch all the way to the end so that you click on the button so that Canvas will record your grade. If it's a notes version, just make sure you're taking notes along the way. I do recommend that you pause the video, try to do it completely on your own, and then play it and see where you got your errors to make sure you really are understanding the content, the major content in Module 3. So here's a good time to pause and welcome back. The Masons were rearranging their furniture, the 50 kilograms. So I'm going to go ahead and annotate that right now. 50 kilograms. Kilograms is a unit of mass. It's in the right set of units. I use kilograms for my force. Okay. Force is equal to kilograms meters per second squared because it's a mass times an acceleration. Okay. The curio cabinet was awkward and they weren't sure if it should be slid using a horizontal force or using an angle of 45 degrees to the horizontal. So we might have a theta that we're dealing with, so we need SOHCAHTOA, or we might not. So it looks like we're going to be doing it both ways. The coefficient of friction is 0.34, that's our mu. What is the difference in applied forces? So I'm going to need to find the force applied for condition 1, and I'm going to compare that to the force applied in condition 2. They both accelerated from rest to 0.2 meters per second. Rest, what does that mean? 0 meters per second. 0.2 meters per second. That is the velocity. Which one? Velocity final. Went from rest, that's our velocity initial, 2.2 meters per second, that's velocity final in 2 seconds, that's our time. Use acceleration due to gravity as 10 meters per second. That's just to let you know not to use 9.8 in this situation. Always read the problem. This does not mean that I use this as my acceleration in the problem. It just means my acceleration due to gravity. So our downward acceleration would be that. Okay, and it might not actually be accelerating because it might have a normal force balancing it out or a force applied balancing it out. So what's the first thing I'm going to do? Draw that free body diagram. And I'm going to look at it and say, do I have all these forces? Yes, I have a force of gravity because that's my mass times gravity. So I have that 50 times 10. Force applied for the first one is horizontal. So that is correct. I do not know what that number is. I will be solving for that number. Force of normal. I do have a surface force. So I will have a force of normal. Force of friction, they gave me a mu. Remember, force of friction is equal to mu times the force of normal. So I have a mu. I don't have a force of normal yet, but it's looking like I should be able to calculate that. So here is my correct free body diagram. And now what am I going to look at first? Where's my easy one? In the y direction. Because it's not bouncing up and down, they're not picking it up. They are just simply sliding it across the floor at a horizontal rate. So my vertical is going to have a sum of forces of 0. So the force of normal minus the force of gravity equals 0. Or in simpler terms, my arrows are equal and opposite, so they're the same length. So my force of normal is going to be 50 times 10. Notice I'm just leaving that as a magnitude because I'm already showing direction with my arrows on the free body diagram. So often in this unit, your answers are going to be positive, even if you're answering for a downward force versus upward force, because we have those arrows showing direction. All right, so now I got my vertical forces. What do I do now? My horizontal force applied minus the force of friction. Am I accelerating? I am. I'm accelerating. So I'm not equaling it to 0. Force applied minus force of friction equals mass times acceleration. So I end up with this problem. Do I know my force applied? Nope, that's what I'm solving for. Do I know my mu? Yep, 0.34. Do I know my force of normal? Yes, 50 times 10, because my force of normal is my force of gravity. So I just substituted out force of normal for force of gravity there. And then my mass on the other side is 50 and my acceleration. So now I'm like, wait, I don't have enough information to solve for a force applied because I need the acceleration. Do I use 10? Nope, 10 is only the force of gravity, the acceleration due to gravity, creating my force of gravity calculation or my weight calculation. Where else can I get acceleration? Go back to the problem. Oh, I have a VI, I have a VF, and I have a T. V final equals V initial plus AT. So I can use that to solve for my acceleration. I get 0.1 meters per second, or that's also written meters per second squared because both those seconds are on the denominator. So just be aware of being able to tell your units apart. Some of you got stuck and put acceleration as a velocity, meters per second, but it's how much speed is increasing or decreasing per second. So meters per second. The speed is changing per second. And so for those of you that struggle with the math there, remember that second one is over 1. And so when I'm dividing by 2 fractions, it's the same as multiplying by the reciprocal. So that's how you get meters per second squared for your acceleration. So now I can plug that acceleration back in and get a force applied. So my force applied, if we are doing horizontal, is going to be 175 newtons. So now let's do it. What if we have it at an angle of 45 degrees? So what is the same? I'm going to have a force of gravity. Okay. Mass times gravity, that one's going to be the same, 50 times 10. I am going to have a force of normal, a surface force, but it may not equal my force of gravity. Go really slow on these. I do have a force of friction. It's going to be, again, mu times the force of normal. That is the standard equation. Force of friction equals mu times the force of normal. My force applied is not, however, going to be acting in the horizontal. It told me it was going to be in the 45-degree area. So I'm actually going to have the force applied is up here at that 45-degree angle. And I'm going to have an X direction and a Y direction. So when I do my sum of my forces, force of normal is going up, force applied in the Y is going up, force of gravity is going down. Force of normal plus the force applied minus the force of gravity equals 0. How do I know it's 0? This piece of furniture is not sinking into the floor and we're not lifting it up. It still said slid. It did not say that they're going to lift it up and carry the curio cabinet. Both directions are slid, so both directions have a normal force. So this one's a little bit more complicated. I don't get an actual number here from the Y equation. So I got to just keep that in mind for when I move on. What is my X equation? My X equation just has force applied in the X minus the force of friction equals mass times acceleration. So that first part of the equation is the same, but then I am going to divert. Why? Because I can't just substitute in force of gravity for force of normal. So what am I going to have here? I am going to have force applied minus force of friction equals mass times acceleration. This is the force applied in the X. And now I can still substitute in, instead of saying force of friction, I can substitute in mu times force of normal. So that part still works. But my force of normal from over here, I got to put these guys to the other side. So force of normal is equal to negative force applied in the Y plus force of gravity. And I just rearrange those terms down here. So here is my normal force for this guy, force of gravity minus force applied in the Y. Okay, so now let's get some numbers in here because maybe some numbers help. Force applied in the X is just force applied times the cosine of theta. Why? Because that was up here at 45 degrees and it's the adjacent side. Force applied in the y is force applied times sine of 45 because that guy is on the opposite side. So now I can say instead of force applied in the x, force applied cosine 45. Instead of saying mu, 0.34. Instead of saying force of gravity, 50 times 10. Instead of saying force applied sine 45 equals mass of 50, acceleration 0.1. Why could I use that same acceleration? Because it said, what is the difference in applied forces necessary if they both accelerated from rest to 0.2 meters per second? Now, in real life, would that happen? No, probably not. If you're going to have an easier way to slide, your acceleration is going to increase, but they put a matching so that it was easier for you to solve that problem. So you didn't have to find the acceleration twice because that's an older standard. And then when you solve this all out, you can find your force applied. And that's 123.7. Then go back. What is the difference? So you're not just comparing there. What is the difference? You're going to subtract those two for the answer. So feel free to watch it again. Email me if you get stuck on any of those points, and have a great day.